Okay, so today I will be giving you a presentation on physical and chemical change. So, before I get into the differences between physical and chemical change, first you need to know what physical and chemical change. So, basically, chemical change is anything that you manipulate and change into a new substance. Like when you bake a cake, there's no way of getting each individual recipe separately. Each they become one and become a different type of thing. It produces carbon dioxide rather than having the eggs and the batter, flour, sugar, and all that separated. It all becomes one to make a new cake. So a chemical change is anything that is manipulated and changed into an altered state. And then you have your physical change. And when you think of physical change, you normally think of like the outer appearance and everything, and that's exactly what it is. So physical change is anything that you can change, but it can always go back to its original state. It doesn't turn into anything new, it just appears different, but it's still the same thing. Like when you freeze ice, it's still water. It's just a solid rather than a liquid. So, examples of chemical change comes for fire, burning of wood, turning when you're in a car, you turn your gas into energy, and there's no way of getting that gas back. So that's chemical changing. Fossil fuels are one of the highest types of a chemical reaction that we have in the United States or in the world, period. And there's no way of getting each, like I said earlier, there's no way of getting each individual thing back. You have a new thing that can go from something new to something new, something new, but it can never go back to what it originally was. Let's see, and then you have your physical change, which I do have a demonstration for physical change. So with physical change, you think of again the same thing: water, ice, vapor. Like you can turn that vapor back to water. So it's like condensation. So when rain falls, it falls into a puddle, and then the puddle gets heated and it becomes vapor, and it evaporates back into the sky, which repeats the cycle. It's like this piece of paper. If I crinkle it up, it's still the same paper because I can fold it back. It's still the same thing. Same way if I were to rip it, I didn't change what it was because it's still paper. Now, a substance cannot be both chemical and physical, but it can have the same things when it's trying to occur. Like, like burning wood. It's still wood, it's just burning, and once it's so it starts off as wood. While it's being burned, it's still wood, but then once it completely burns, it's ashes. So it just goes from one state to the other. It's still the same thing, but so that one is an example of having both chemical and physical. Well, it's not having chemical and physical, it's just converse before it becomes the new substance. So in the middle of the process, it's still the same thing, but it's still eventually a chemical change. So you'll still consider it a chemical change. It's just you can have both things at once. So my 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 conclusion with doing this research is that physical and chemical changes happens all the time. Some of the stuff you can see, some of the stuff you can't see. You don't see the gas burning in your car, but you know your car is moving somehow. You don't see it every day when ice melts. When your slushy melts, you just think, oh, I'll put it in the freezer. You don't think of it as, oh, this is a physical change. This is a chemical change. But physical and chemical changes happen every day. Like you see it all the time. When the sun beams down on your garden and makes your flowers sprout. That becomes a chemical. Is that a chemical change? I don't know. Now I know what I have to research. So, well, I think it's a chemical change because when you plant a flower, it blossoms, but at the same time, it drops seeds. But so technically, planting is a chemical change because when I plant it, there's no way for me to get that specific seed back into that specific flower. If I'm wrong, can you let me know? All right. So I hope that you